And so then it becomes very complex now that you have many possible very good solutions that provide different trade-offs between, let's say, habitat versus building versus watershed. You need the user, the human decision maker, to kind of see through them and understand which one would they decide to implement, right? So then it becomes also beyond just doing algorithms and AI, you have to think about how these things are going to be incorporated into actual decision making on the ground. And so that's why we worked with computer scientists that work more on like human-computer interaction, visualization, to help us plug these things into a visualization where it might make sense to an actual decision maker. And how did we go about understanding what these needs are? We actually worked very closely with people from U.S. Forest Service, and in particular from the Yosemite National Park, where indeed they are planning for this prescriber, and that's a real problem that they want to solve. And they shared with us, again, the real data about the planning units, the costs, and so on. And we applied our approach and worked with them to understand how we can help them use those outputs in a way that will facilitate their decision making. So we created this is very small, but it's an interactive kind of web interface where they can explore the solutions that come from the AI tool, where they can look at the different metrics. They can decide, like, I only want plants that save at least X% of the habitat, but I also want plants that only, consider only at least that much buildings protected as well. And then within that, kind of start exploring which are the solutions they might land at, and also look at the actual geographic, again, spatial extent of these benefits. So the recurring theme is a real world problem that's very complex, that requires, a complex technological solution, but also has real users at the end, and having this iterative approach of working closely with the actual stakeholders and partners, understanding their needs, making solutions and refining them such that it actually has some pathway to making it into a real decision making, and not just writing academic papers about it. I don't know if I should take questions in between or just for the end, maybe for the end. So this is kind of on the environmental justice. I want to give you a couple of examples. I don't know how I'm doing on time, from our center's work on homelessness. Obviously, homelessness is a huge issue across the US, but in particular for Los Angeles. And so thinking about how we can leverage our expertise, again, to help this thorny societal issue is one of the key focus areas for our center. In particular, recent statistics, there's more than 75,000 individuals that are experiencing homelessness across the LA area, and yet in terms of housing resources for the homeless, we only have a little bit more than 28 permanent or semi-permanent housing. So it's clearly an unmatched resource to need area. In addition, there's also huge inequalities in terms of how different sub-communities are affected by this problem. For example, there's only about 9% of LA residents are Black, and yet 40% of the people experiencing inequality are actually Black. So basically our focus is how can we use data-driven approaches to help this, do prioritization and allocation of these limited housing resources in order to advance equity and improve the system efficiency and impacts on alleviating this problem. So this work is led by my colleagues, my co-directors at the center, Professor Eric Rice and Professor Phoebe Vallanos. And they're working very closely with the Los Angeles Housing Services Authority, LAHSA, to actually understand this problem and develop solutions. So their goal is to increase persons that are housed in equitable and fair way. And so they want to improve essentially what's called the triage tool, which is the tool that LAHSA uses to evaluate the needs and the level of vulnerability of people experiencing homelessness that come to request services. And this has been a long project with a lot of, again, interactions and feedback loops, understanding the problem, proposing solutions, and getting showing possible impacts. So after this, at the end of these 3 years' work, and I mean it's an ongoing effort, basically what my colleagues have managed to do is use historical data about homeless individuals in this area and their answers to these intake surveys, the impact of the resources that were allocated to them in terms of exiting homelessness, and developed a machine learning kind of a predictive system that's able to assess this vulnerability in a different way than the current status quo. And basically by looking at historic data, they've been able to show that were this system, more sophisticated machine learning system being used, they would be able to, first of all, increase the efficiency of the system, which means more people would exit homelessness due to the resources that are provided to them by 3%. But even more importantly, those benefits across the system are also distributed more evenly. So here you can see here the historical kind of benefit of proportion of individuals exiting homelessness divided racially under the historic data versus this expected distribution of these benefits under these new data-driven policies that they've developed. So now they're basically in this process of really incorporating and deploying, piloting some of these new prioritization policies based on their work. And the second example I want to show from another one of my colleagues in computer science, Wabla. She's an associate director together with Professor Eric Rice at Social Work and their students, is again looking at different aspects of how we can leverage AI for this turning problem. And here we are looking in terms of how can we leverage AI to understand better public opinion about homelessness. As you know, public opinion is an important driver for advocacy organizations, and understanding public opinions is very important. And in particular, social media is a huge trove of information about public opinion, and yet it's really, really hard to harness to understand what those are, especially for social science researchers. So here in this project, what they were trying to do is understand, can we leverage the newest of the newest, ChatGPT, like large language models, to help us process this text in a way that actually will feed into social understanding about public opinions on homelessness. So what they did is they basically scraped the internet for tweets and found more than 3 million tweets that were somehow related to homelessness. Now, 3 million is a huge number. No individual human or a group of humans or many humans will individually go and like classify them, right? It's a huge undertaking. So what they did is they actually got a team of people at USC to manually label 4,000 tweets out of the 3 million, and that still took hours and hours of work. But helped them basically have like this kind of tagging for each tweet. Was it about government criticism? Was it about money and aid? Was it about harmful generalization about homeless individuals? Was it about some kind of interaction with homeless individuals, etc.? And so with this, then they went and developed a framework where now they had this kind of like manually labeled 4,000 things. What they did is they designed a system where they would prompt. So what prompted? I hope, how many of you have used ChatGPT? Very ChatGPT. Okay, so maybe I have to start with what is ChatGPT? So, you know, like right now, you know, in Google search you type and you kind of get an answer in terms of like basically matching to existing websites or documents that can be found, right? Large language model, of which ChatGPT is one example, but there's many of them, are just like basically state-of-the-art AI platforms which leverage all of the information on the internet to learn how to synthesize information and also generate new text, right? So if you ask ChatGPT, please write a bio for Bilstra Dilkina, it would actually not just find a website that has my bio, it will use all the information that's out there and generate, synthesize novel text that represents that knowledge. But you could also ask new things like, write me an essay about XYZ, and to write something. So it's really powerful. Obviously, it has a lot of problems in terms of making up stuff. So it's really thorny. It's very like it's very powerful, but it's also problematic. So it has to be used with caution. And one of the big things that how used with caution can be done is what's called like how do you prompt it? How do you ask it? And so there's a lot of kind of science going behind of how do you formulate what you, so for example, in this case, they're trying to create this ask or this prompt that they would give ChatGPT, which will say something like, I am classifying tweets about homelessness. I would like to classify them into these 6 categories. Category A refers to XYZ situations, and you actually write it as a text, as a formal definition, and you give that into kind of like this prompt or this question to ChatGPT so that it gives you more meaningful answers back. But what is this correct prompt? So what they did is basically worked with experts in the loop where they had some initial idea of what this would look like. Then they would ask ChatGPT to give them answers back in terms of how it's labeling these tweets. It will be wrong. The experts would look at it, and based on those mistakes, they would think about like how should we modify the definitions or like the ask such that it doesn't make those same mistakes again. So it was like an iterative process with experts in the loop to create that. And once they converged to something that was actually correct most of the time, they basically used this to label a new set of 4,000 tweets. Now with this ChatGPT kind of doing a first pass on the labeling, and then the experts just tweaking a little bit the labels, like saying, oh no, this is wrong, this is right. And so what they found is that by doing that, they're able to speed up the process of labeling 6 times, just because a lot of the cognitive effort of like reading through is already done by this AI system, and then the experts can just quickly look at like some of the glaring mistakes. And so now that they were able to do this, they had a much bigger set of like labeled like tweets that were correctly assigned to different opinion categories. And with this larger set, they were able to now train a standalone machine learning framework that would just take tweets and classify them, that was working quite accurately. And so with this, they were able to apply all of that at almost all of the remaining homelessness tweets, more than 2 million, 2.4 million, and that obviously opens that trove of information that I was alluding to earlier about, can we study now public opinion at scale by understanding, you know, this, what? Fell asleep, that should not happen. About like what are people thinking on social media and their attitudes in different categories. So as I said, they were able to do this 6.5 times faster and be able to create this model that then can classify millions and millions of tweets. And then that opened the door for a lot of further analysis. They've only scratched the surface, but here is something that you can, for example, learn from these 2 million classified tweets in terms of how often are different attitudes towards homelessness in the public. So here's one category, which is the NIMBY category, not in my backyard, which is basically opposition by residents to proposed developments in their local area, etc. And they are able to do statistics like in each state, what's the percentage of homelessness tweets that are more aligned with this attitude versus something else. And so again, you can see how this can inform both policy as well as advocacy organizations in terms of understanding and then targeting messages to different places. So these are just some examples. The last category is health and mental health and equity. We have many projects within this space. I have one short example again of my other colleagues. My personal project that I'm not going to present today, but that I'm really invested in right now is I'm actually working with collaborators from the USC School of Medicine and with AMREF, which is a huge NGO working on health in Africa, and we are working in Kenya, where we are trying to develop a system that is able to predict malnutrition among children 3 to 6 months ahead of time, so that organizations like AMREF can think about where they would deploy what they call nutritional baskets. They'll basically prepare these baskets with like basic nutrients and deliver them to families in the areas, anticipating that there might be an increase in malnutrition, and therefore providing important health benefits for these children. But here is another example, which is led by two of our co-directors and associate directors, which is looking at another set of vulnerable populations, active duty soldiers and youth experiencing homelessness. We know that mental health is a huge crisis across the US, but specifically really impacting specific vulnerable populations like that. And so they're studying how they can understand what can help mental health across these two particular populations, in particular looking at mindfulness. So mindfulness is a practice that has been shown that it can really have a positive impact on mental health. And so they're looking at, can we increase mindfulness adoptions by understanding the social network, meaning how people talk to each other and spread information about practices such as mindfulness among them, as well as help-seeking behavior. And by using data-driven approaches and AI to improve our understanding and predictive powers, if I teach this person about mindfulness, how likely is he to spread that knowledge to their friends, and they spread it to others, and therefore have a larger impact across the community? We can really increase kind of the intervention and propagation of these benefits. So in conclusion, so this is just a few examples. We have many more. We're very excited. There's a lot of faculty and students working on this. And all this could not happen without our past and current funders, which include national foundations like the National Science Foundation and the National Institute of Health, but also a lot of foundations and nonprofits like the Hilton Foundation and the Paul Allen Family Foundation, big companies like Microsoft and Google, which have arms that are dedicated to this kind of initiative, as well as several private donors that have been very generous to our center. So with that, thank you, and happy to take questions.
One question.
How many
Oh, you're good. We're
okay.
introducing
Yeah,
Jessica as well.
45 minutes.
Yeah.
Right, yes.
Dr.